Discussing about the covalent versus ionic nature with respect to the compound Z. Now we all know this compound NaCl. Here, sodium likes to release an electron because it is a metal, while chlorine likes to take up this electron because it is a non-metal. Now you can see there is a positive charge and a negative charge existence here. So when in your 10th standard, when you have learned it, you would have seen people writing Na plus and Cl minus. The presence of this well-defined ionic system tells you that they are having ionic interaction between them. This ionic interaction leads to a bond called as ionic bond. So such a compound which is having this ionic interaction will be called as ionic compounds. Now if I'm talking about, let me say I'm talking about CCl4. Carbon is bonded with 4-chlorine. We know that carbon is also a nonmetal, chlorine is also a nonmetal. So the bond has happened between two nonmetals itself. So in this category, in the previous case, we said that sodium loves to give up the electron, so it's a metal, and chlorine wanted to take the electron as it is a nonmetal. But here both are nonmetals. And in this case, which would like to push or which would like to give? There is no necessity here. So therefore, what happens? The bond that is formed between them is having mutual sharing of electron. The bond is made by mutual sharing of electron. This mutual sharing of electron leads to a bond called as covalent bond. And such compounds will be called as covalent compounds. Tell me about.
The electron is like not of C and not of Cl, it's like Cl.
I can't hear you properly.
So that electron is both C and Cl, like it belongs to both of the atoms.
Both of the atoms, that's right. Mutual means that is what is called as mutual. You say mutual friends, isn't it? Both
Yes,
are
ma'am.
having the equal share there. Both are sharing the electron there. Now we will understand about the differences between the ionic compound and the covalent compound. So how is an ionic compound formed? By the transfer of electrons from a metal to a non-metal. Look at here. Sodium is a metal. It transferred its electron to a non-metal. How is a covalent compound formed? It is formed by sharing of electrons between two non-metal atoms. In carbon tetrachloride, you can see they are sharing the electrons between two non-metals. So such compound will be called as covalent compound. Now as we said, I am writing the charges on them, plus and minus. We know opposite charges loves to attract each other. So definitely there will be strong electrostatic force of attraction between the cations and the anions. They love to come in close contact with each other. Since there is a mutual sharing of electron, carbon says, see, I gave this electron. Chlorine says, I gave this electron. So both carbon and chlorine are individually providing their electrons there. Because of that, there is no strong interaction between them. See, your two friends are there. Assuming that this friend is always buying you snacks, taking you to the bakery, always giving you snacks. Definitely, you will feel very happy about him. You never want to go out away from him. You always want to be in close proximity with him. There are two other people where one day this fellow buys, second day this fellow buys. So they are doing it in a mutual way. Okay, I buy, you buy. So in that case, they won't be having that much of interaction between them. He will think, okay, I'm buying for him. Why can't I go and make a friend with someone else also? That is not that much privilege because of being in friend with him. Similarly, this fellow also will think. Why don't I go and go join with someone else also, right? So this is how the covalent bonds are. Because of this mutual share only, they're having weak force of attraction between them. Now this answers why they are solids at room temperature. Because of the strongest electrostatic attraction between them, what happens? They are very close with each other. Because they are very close with each other, their intermolecular force of attraction increases. If the force of attraction increases, it's obvious that they become solids. But covalent compounds are having weak force of attraction. Because of that, they could be gases, liquids, also soft solids. Soft solid means they are not going to be that much rigid enough. They are also soft solids here. The next point. As we said that they are having this ionic form there. So I am taking sodium chloride, I am going to put it in water. It will exist as Na plus and Cl minus. They are present as ions here. Ions generally carry electricity. Consider you are going to take a fresh water from mineral water. Okay, I'm going to take mineral water and I'm going to pass electricity through it. I'm going to fill the bucket with a tap water. I am passing electricity through it. In which case, the electricity will pass. In which case, do you think the electricity would pass?
First case, ma'am.
Which case? Mineral water case.
Yes, ma'am.
Why do you think so?
And because in that we have ions which can like carry the charge.
The mineral water is a water that you are getting in your home, da, RO, where all the ions are removed basically. Correct, na? Don't think that children,
Yes, ma'am.
because the word is mineral, don't think it is containing lot of minerals there. Actually, we should call this demineralized water. You don't contain anything there, it is just H2O there. But in tap
Okay,
water,
ma'am.
you have so many ions, Na plus, Mg2 plus, Ca2 plus, so many are there. So they will conduct electricity. That's the reason why during this rainy season, whenever this current poles are cut and the electric wires are running in the falling on the water, you can see so many people get electrocuted there because that rainwater, when it came, was pure only. But once it ran throughout the garbages, every places, it right now carries so many ions inside it. So only it conducts electricity there.
Ma'am.
Tell me that.
And then why is RO water called mineral water?
Actually, you should not call it as mineral water. That's what I'm saying. It's an irony here.
Okay, ma'am.
You should not call it as mineral water. These fellows have kept its name like that. Okay. So they conduct electricity in molten state and in solution. So in molten state also, a little bit they can become free enough so that they will be able to conduct electricity. But what about solid state? In solid state, they are very intact. So in that case, you don't have mobile electrons at all. No mobile electrons. So they won't conduct. NaCl, aqueous NaCl, and molten NaCl can conduct. But solid form of NaCl cannot conduct electricity because they don't have mobile electrons. Of course, we are talking about covalent compounds here. The electrons are mutually shared between them. There is no free electron at all. So they are non-conductors of electricity. Next point. Due to this highest intermolecular force of attraction, too much is attraction. If I want to melt it, if I want to boil it, I have to give so much temperature here. So they have high melting points and boiling points. Since covalent compound is having low IFA, they have low melting points and boiling points.
Ma'am.
Yes,
Ma'am, if these college bonds are weak, how are they stable, ma'am?
we are saying they are weak, but we are not saying they are unstable. There is a difference, isn't it? We are comparing, see, for example, um, let me say I am comparing with the very strongest person. You know Arnold Schwarzenegger?
Yes, ma'am.
Yeah, that Switzerland fellow. So he is the strongest person here.
Terminator.
Yeah, Terminator, correct. He's the strongest person here. He is strongest. Now, when I'm going to compare, uh, let me say I'm comparing some boxing champion or some other champion of our own India. He is also strong only. But when I compare with Arnold, he will not be that much strong. Do you understand? I'm comparing this covalent compound with
Yes, ma'am.
ionic, which is very strong.
Yes, ma'am. Listen, ma'am.
Yeah. The next one is this soluble in polar solvents. You can see there is existence of charges here. Existence of charges. Existence of charges makes them polar. Polar means separation of charges. Since they are polar, they will dissolve in polar solvents. Light dissolves light. You will be in friend with the person who is having a similar mentality like you. For example, if you love to play cricket, you will love to have friendship only with the person who loves cricket. You won't go and make a friendship with the person who is playing chess there. Same happens here. Since this is polar, it will dissolve in polar solvents only. The best example for the polar solvent is water. The best the best one for the polar solvent is water. Okay. So now when I'm going to dissolve an ionic substance in water, it is very easy and comfortable for it to dissolve. 1 minute.